Have you ever stopped to think about how you can be on a video call, downloading a huge file, and have, I don't know, a dozen websites open all at once without everything just completely crashing into a chaotic mess? Well, there's a hidden traffic manager making it all happen. And in this explainer, we're going to pull back the curtain on this unsung hero, the transport layer.
So let's kick things off with the scenario that you see every single day, but is actually a really fascinating technical puzzle when you look under the hood.
Yeah, this probably looks a lot like your screen right now. It's just modern life, right? You got messages flying back and forth, emails coming in, a ton of browser tabs open, maybe a voice call going, and you're streaming some video on the side. All of this is flowing through one single internet connection. So here's the big question. How does your computer possibly juggle all of that without getting confused? I mean, what's stopping a little piece of that video stream from accidentally landing in the middle of your email draft? It really does feel like magic, but it's not. It is some absolutely brilliant engineering. The answer to this incredible multitasking madness, well, it lies in a very specific part of your network's architecture.
Let's meet the transport layer. Its whole job, its entire reason for being, is to move data between the actual applications running on your devices. You can think of it as the ultimate middleman, sitting right between your web browser or your email app and the lower parts of the network that just focus on getting data from point A to point B.
Now, the technical term for this juggling act is multiplexing. It's this process that lets all your different online activities, your email, your web browsing, your video streams, all share that same network connection without stepping on each other's toes.
So the transport layer really has two main jobs. First, it acts like a mailroom sorter. It uses something called port numbers to make sure the data gets delivered to the correct application. And second, it takes big chunks of data and chops them up into smaller, more manageable pieces for the network. We call that segmentation. This is the best way to think about it, I promise. An IP address is like the street address of your apartment building. It gets the data to your computer. But the port number? That's your specific apartment number. It's what tells the system if this piece of data is for apartment 80, which is your web browser, or maybe apartment 110, your email client. It's that specific. But the transport layer isn't just one single thing. It has two different specialists, and they have very different ways of getting the job done. So let's meet them. First up, we've got TCP, the Transmission Control Protocol. You can think of TCP as the perfectionist. It's obsessed with reliability, making absolutely sure that every single piece of data arrives and arrives in the correct order. And then you've got UDP, the User Datagram Protocol. UDP is the speed demon. It's all about getting data there as fast as humanly possible, even if that means cutting a few corners on reliability. And this right here shows you why you need both. When you're writing an email or loading a web page, every single byte has to be perfect, so developers use the reliable one, TCP. But for something like a live video or an online game, speed is everything. A slightly pixelated frame is way better than a 3-second delay, so for that, they're going to choose the speed of UDP. All right, let's take a closer look at our first specialist, TCP, and really understand what makes it the reliable workhorse of the entire internet. TCP is what we call connection-oriented. What that means is it doesn't just start shouting data out into the void. Nope. It first establishes a formal connection just to make sure the receiver is actually there and ready to listen. It's kind of like waiting for someone to say hello on the phone before you start talking. It's just polite. And this little hello process has a name. The three-way handshake. It's simple, really. First, your computer sends a little synchronized message, basically asking, "Hey, you there?" The server replies back, "Yep, I'm here, and I'm ready." And finally, your computer sends one last confirmation saying, "Awesome, here comes the data." Only then does the actual conversation begin. So how does TCP guarantee every single piece gets there? This part is super clever. It uses what are called sequence numbers and acknowledgement numbers. Think of the sequence numbers like page numbers in a book. The receiver then uses acknowledgement numbers to say back, "Okay, I've got everything up to page 10. Go ahead and send page 11 next." It's a brilliant system built right into every single TCP packet.
You have to remember, data zipping across the internet can take all sorts of different paths, which means it can arrive all jumbled up and out of order. But thanks to those sequence numbers, TCP's superpower is to act like a librarian, patiently reassembling every single out-of-order piece back into the original perfect message. It is incredible.
Okay, so we've met the perfectionist. Now it's time to meet the other specialist, UDP, with its famous fire and forget approach.
You know, the key to understanding UDP is really to focus on what it doesn't do. It's connectionless, so there's no three-way handshake. It just sends. It strips away all of TCP's fancy reliability stuff to achieve one thing and one thing only: maximum speed.
And this slide right here shows the trade-off perfectly. With UDP, data packets can also arrive out of order, but unlike TCP, UDP doesn't care. It doesn't fix it. And if a piece gets lost along the way, well, it's just gone for good. UDP doesn't even know it happened, so it's certainly not going to try and resend it. I love this analogy. UDP is just like sending a postcard. It's super fast, it's simple, it's efficient, but you don't get a delivery confirmation. You just drop it in the mail and hope for the best. That's UDP in a nutshell. Okay, so we've met the reliable perfectionist and the live fast speed demon. Now let's bring it all together and see how this choice directly impacts your day-to-day online experience. So to sum it up, TCP's insane reliability makes it the perfect choice for things where every single bit matters, like your email, a web page, or a file download. Meanwhile, UDP's raw speed makes it the undisputed champion for real-time stuff like live video streaming or online gaming, where a tiny little glitch is always better than a long, frustrating delay.
And there you have it, the secret traffic manager of the internet. So the next time a web page loads flawlessly, you can give a little nod to TCP. And when your video call gets a little choppy but still keeps up with the conversation, you'll know that's UDP doing its job. So think about what you're doing online this very second. Which one of these specialists is working hardest for you?